All right, so folks, we're going to get started. I am going to introduce Tristan, talking about introducing BuildStream, a distribution agnostic build and integration tool. So let's give him a hand and say hi.
Let me put this. Hi. So I've come to talk again about BuildStream. It's been a year, and now it's time for the second talk. Last time I didn't go through this in the right order. So what is BuildStream, right? So before I start talking, what is this guy talking about, right? So what is it? So it's an integration tool. We're trying to call it an integration tool because we've been calling it a meta build tool and nobody really knows what that means. So it's a tool which builds, but it's not make and it's not CMake, so it delegates builds to other systems and it puts it all together and you have an integration. It's an integration tool. BuildStream is a pipeline of file system data permutations, so it's completely abstract and it lets you run operations inside an isolated environment in a pipeline where elements have source inputs and dependency inputs and they create outputs. So the basic of it is you have file system data in, file system data out, and things that happen in between. Sandbox execution environment, so we guarantee there's no host tool contamination or anything, and everything happens inside a container. We do caching and sharing of build results, so if you have a lot of people building together, already built something, you don't have to build it, we'll download it if it exists, and we reduce the amount of compiles on the developer laptop at least. And multi-purpose build instructions and metadata is to say that you can have a project that outputs various things with the same stack. So generally in BuildStream you're going to be working with a series of components and not just one component, but we have an example at the end with just one component and a way to distribute it. But you can basically have projects that have different outputs and using the same stack, so you don't have to have various collections of build stories for your software. And it has a developer story, which is late in the discovery process we found out that's actually the coolest thing that we do, probably. So on to the show. So I'm going to introduce our BuildStream Beaver. It was our youngest team member who we affectionately call Tristan because he's so bright and it's also his name, who said that it should definitely be a beaver because a beaver builds things in a stream. So here I've launched an Epiphany build, but I can see that we really can't see this very well, which is unfortunate because I have a lot of these screenshots. You can't see that, huh? Okay, well, I'll have to explain as we go along. So what are our motivations for doing BuildStream? So I'm going to try to jump through this segment because it can be a lot of talking. So one of the things we wanted to do, of course we want to save time. We're in automation, we're automating stuff. We want to reduce the amount of work that people are doing. So we want to kill cross-compilation because from what I've seen, there's a lot of developer hours in projects spending, and these are like really good developers that I've worked with in other projects, and I'm like, what are you doing? They're spending their days writing these one-line patches and upstreaming these one-line patches to projects to make sure that they compile cross upstream. And we think you only really need to cross-compile the tool chain, and once you have a tool chain and you have a kernel, you can boot hardware, and from there you can just native compile. So if you can do that, and if we can provide a system that lets you do that, then we can save on all of those developer hours doing menial tasks, and I'm sure they'd all love to be actually creating something fun instead, right? So smoke testing builds on new build host platforms. Some tooling which uses host tools a lot, they need to be vetted for a new distro. So the new version of Ubuntu or the new version of Debian comes out, it's not supported by, say, Yocto or BuildRoot or something, and you have to spend a month or something fixing the bugs, and well, we don't want that either. Complicated setup. This more pertains to like historical build tools which have been invented like more than 20 years ago, and we have to keep using them because everything depends on them, but we end up like setting up OBS and these huge setups that are not easily repeatable setups, but they work well, right? But you can't just set it up on your laptop in 5 minutes and build something repeatable with that, right? Monolithic repositories of build metadata. This pertains to projects like BuildRoot. I don't know if probably everybody's distributions devrim, you all know about build tools, I'm sure. BuildRoot, Yocto, these kinds of projects which have metadata in the same repo for the whole stack, from the runtime to your graphics stack and everything. What I've noticed is you have a lot of friction in integrating patches, especially in the lower level of the stack, or people generate a lot of breakage in the upper parts of the stack by prematurely merging stuff in the lower level of the stack, because upgrading GCC or upgrading glibc has side effects which are forced upon the consumers, right? So we wanted to reduce friction, and for that we have a feature which lets one BuildStream project depend on another BuildStream project, so you can have completely separate projects maintained by separate groups and separate teams, and higher level depending projects can pull in the changes when they're ready, test against them, report back bugs back to the lower stack maintainers and such like this. We hope it's going to be a better workflow, but we're putting it in action now, and we're going to see how that works out for us this year. So yeah, we don't want tight coupling of build systems and distributions. In distributions, what I mean here is the payload, right? In a lot of cases, cross systems especially have a tendency of writing tools for the specific software that they're gonna build, and that makes it difficult to take a tool that has been made to make this distribution and use it to make a completely different distribution. So you're kind of stuck with certain versions and certain setups depending on the tools that you use, and we didn't want that to creep in. Yeah, so what about the developers, right? So we generally think about, in the integration crowd, we think about the developers are those people who just like hack stuff and run it on their laptop, right? And then they send us a patch, or they send us a new source RPM, and we're supposed to integrate it, and they said it's fixed, right? But they never tested it on the integrated system, and we blame them for it, but it would have taken them all day to like get a rig and find out the process for building it on OBS, you know, finding the process for flashing it to a rig and doing it. We didn't really give them tools to make it easy for them, so I think that we're blaming the wrong people here. Okay. So a little segment on what we're doing about these problems, how we're tackling them. So kill cross compilation, right? So for this we're we're looking into features which let the sandbox execute under a given machine architecture, and we have an abstraction layer for that, and it's probably coming in the next 6 months. We might see something materialize here. It's designed for this, and right now we only support native builds, but we're gonna do it, I promise. Yeah. So that will be just a way that your project can declare, or a configuration option can say, try to build this on that hardware. And it may require that you run a virtual machine to provide an emulated environment on your own laptop, or that you're connected to a build farm and you have real hardware or development boards to actually run the builds, and they just act as slaves to the build process. No host tools. This is thanks to Jörg Billeter, who said we shouldn't have host tools. And I said, you're crazy. But yeah, it makes a lot of sense. No host tools. We just cut a lot of problems at the bud. If you can have a host tool on your computer, there's no reason you cannot have the same host tool in an SDK or in a sysroot. So everything is controlled this way. Right? We track every hash of every binary input into the build, and there's nothing left to chance by saying no host tools. Make it easy to run the production environment. I kind of already covered this. So the tool itself, if it can run, it's running something that should produce bit for bit, if the source is ready to do bit for bit reproducible builds, it should be doing bit for bit reproducible builds on any machine. So the time it takes you to set it up is the time it takes you to set up a production environment. And right, so reproducible and repeatable, I've kind of been making a distinction here. Some people are telling me there's no distinction, like Emmett. But so reproducible builds is getting your builds to be bit for bit repeatable, so that every time you build it you get exactly the same output, and you can raise your level of trust a lot in the things that are being built, because you know things that are already tested. And on the other side of the story is when you want to repeat this process 10 years from now, and you have this definitions of everything that you want to build and how to deploy your appliance or whatever it is you're doing, right? It's important to be able to actually repeat the setup of creating a build machine from scratch, because, well, we want to keep our eyes on how repeatable the process is, because we can't say right now what the world is going to be like in 10 years. Of course, we'll want to CI this along the way. So we have processes and a way in place. We have a technique in place that lets us cross-compile a base runtime and kernel and boot that just to run a shell script without an init system or anything, which will consume some build instructions that we've generated into a script, which will let you at least bootstrap a foreign architecture machine to a point where it can at least run BuildStream, and then you've completed the process and you can always do it again. All right. I'm gonna run through this because I have a walkthrough for you instead. So, multi-purpose build metadata. I create an app. I have to choose if I'm gonna build. Am I gonna build a flat pack? I have to build it myself, right? If I want to build a snap, I have to build it myself. If I want to build a Debian package or an RPM package, usually somebody's going to do it for me. But in any case, it would be nice if I don't have to maintain like 3 different subdirectories of my module to say, well, this is how my OSX bundle works and this is how my Flatpak bundle works. I just want one build instructions, right? So we want that. So basically tools to debug inside my target environment. You have to put tools into your runtime if you want to use them in your runtime, but we have some interesting tools that I'm going to show off in this talk that cover that. Artifact sharing, so I want to test GTK against the latest Epiphany and WebKit and see what side effects happen there. I should be able to do it without rebuilding the whole world because somebody's probably built it. Testing the changes. Okay, fun. So now I'm going to have to look at the screen here. So when you write BST show, oh my god. Okay. Let's just try to hold this. Right. Like, can you see the, you can't even really see the colors here, right? So
we can see that there are colors.
You can see that there are colors, yeah, but you know, yeah, this is not helping, yeah. So basically we're saying that all of these elements are cached. These are cached in purple. These are cache keys, so basically they're a stamp. They're abbreviated SHAs, which represent the inputs of a build, which is our prediction of whether it should be bit for bit reproducible or bit for bit exactly the same. So this one is GST plugins bad, has that SHA, right? Everything is built. So I have an Epiphany that's built and I want to hack on GTK. So I'm going to open a GTK workspace. Here I'm saying BST workspace open, and then the element gtk3.bst, and then a directory, right? So the gtk3.bst is a file which defines how to build GTK and stuff about GTK. And here I've basically checked it out at exactly the version that I was going to use to build according to this project data, and now I have all the source code inside. So just keep in mind that after doing this, I've opened up Emacs and I've reversed the GTK label angle so that by default it's at 180 degrees. So labels should be upside down. I won't go through that. So I'm going to show it again and just see what is the result and hope that, yeah, you can't really, huh? Ooh, okay, well this one is green, it says buildable, that's GTK. And here, waiting, right? Here we have WebKit here is waiting. Everything that depends on GTK basically says, well, GTK is ready to build and this is my pipeline. This is what's going to happen if I run a build, right? If I want to see Epiphany with a new GTK, I got to build all of that. But I don't want to build WebKit, all right? So let's try without strict mode. Strict mode is by default, everything has to be built. Every reverse dependency has to be rebuilt when something changes, which is what you would want in production builds. But without strict mode in place, then we just say that I'm going to test something with the exact version of everything, but I'm not necessarily going to rebuild against everything. So I'm going to lose out in places where I need to do static linking. For that I need to add extra sugar to my project to say, well, no, I need to be rebuilt strictly every time because I consume static libraries. But mostly this works in a Linux environment where everything is dynamic. You can test. So here, what I wanted to show you, and now that the lights are off, you can see the cache keys. It says cached for everything except for GTK, which is buildable. But the cache keys have changed color. The dim ones are the weak cache keys. They're calculated differently. We're falling back to these ones. We're going to use them. And those ones won't be pushed upstream. Things that get rebuilt, in this case, GTK, won't get pushed to a shared artifact cache because it's just a local workspace. And this lets us just whip it up together, right? So, oh yeah, I was going to build this, but Buddy told me he had a fix in GStreamer, so I want to check that out and add this to my build first. So for that, I'm going to track, right? I'm going to track GStreamer, and we don't really see well, but there's an info. He says, I found a new revision. So basically, inside the file which defines how to build GStreamer, you have the upstream URL, and you have a tracking branch, and you have the commit SHA that you want to build. So BST track will basically take the branch information and use it to derive a new commit SHA and say, well, let's update your project such that you're building the latest of this component, or you can do this recursively or not, right? So here I've done git diff, and I can see this, well, there's this red mumbo jumbo which has gone away, and some green fuzzy stuff which they're commit SHAs, right? So can we build it, right? So now we see, before we go, well, now we're trying to build it, right? Before we go, we have this buildable, which is also GStreamer, but it's also in non-strict mode. So we're going to build just two things. And right now we have our cute UI who's clicking away here. Sam really loves the UI and the colors, so I'm going to try to sell it in his name. Yeah, we've got something pretty interesting. It's just a little hack with terminal ANSI escape sequences, which lets us like reserve some lines, and we have our rolling log, which will just keep going, and you can redirect that to a log file or something. But while you're watching the build, you have this, which just sticks at the bottom. And you have your different queues here. So I've pulled no elements from upstream, and there's three actually. There's 0, 2, and 0. Red is failures, right? So you have your three queues, and you can see the things are moving through the queues, and we have counters to say, okay, what are we right now doing? So we're basically scheduling everything that's going on here. And we have a full timer, so we've been going for 1 minute and 20 seconds on this slide. All right, well, not bad, not bad. So I ought not to wait for it to build. When it finishes build, it will tell you, yay, we built, and you don't need to know. But what is interesting is that GStreamer finished compiling before GTK3 even got to make. So GTK3 was running configure, and GStreamer, which switched to Mezzin, just like speeded right through configure and like killed it in this race. Yeah. So it looks like Mezzin is a good idea after all. So now I've built everything. I've got my upside down labels, I think. And now we can run a shell, right? Oh, this is even worse. Oh my God. Okay, well, that was BST shell epiphany.bst, right? And basically what we're doing here is we're taking all the different little builds that we have, basically every artifact is like the make desc dir equals foo install output stuff. And we have a deterministic staging order dictated by the dependencies of everything, and we just whip them up into the same directory with hard links. And we run some integration commands. Right, so we update like G settings, schemas, and stuff like font caches and things after staging everything. We also do this before every build, right? So every build has exactly what you expected. So here I launched Epiphany from the shell, right? And you have your upside down loading here. We don't render this with labels, but we're online, and we have this upside down text here, right? So we know that we did run Epiphany with the GTK that we hacked to turn the labels upside down, at least. There's some problems which have been reported about, like Epiphany specifically. It needs to access the web, and in the regular testing shell environment, we allow, like, we don't unshare the namespaces or unshare the net or anything like this, so we don't use a secure container environment, but we still have to like echo name server 8.8.8.8 into resolve.conf in order for it to work, right? So there's some little tweaking. We're thinking maybe some client-side configuration or project level configuration that says this is how you can create a shell environment where my applications should run, but that can use work, you know. It's better to go with a VM. It's better to actually distribute what you're done, right? So you never know what's on the host anyway. So pipelines. BuildStream is elements and pipelines. So let's take a look at what some plausible pipelines could look like. All right, to give some idea of what's going on. So this one is generate an image, right? So we're not going to do this, but we thought of doing this. Right now in GNOME, what we have for building GNOME components is we use a dbootstrap base, which lets us just say, okay, I don't care about my system dependencies, I just want them to be there, and I want to try to build and run stuff. So at least we have a specific version of, we're using Debian testing, and this is orchestrated outside of a build pipeline because you cannot really run dbootstrap or multistrap twice and expect to have the same binary result. So we run it on a server continuously, and when we add dependencies, it gets re-executed, and the result gets committed into an OS tree repo, which is controllable. So we have a couple of hacks like this to make sure we get policeable data into the pipeline, right? So here we import from an OS tree repo, and then we build stuff. So we can import the base system and build stuff, and then we can use a compose element. A compose element is going to take what you want out of what you built and make one output, which is usually a lot smaller than what you had when you just used everything that was in make install, right? So you want to decide, do I want my debugging symbols? Do I want all the documentation? And you can tweak your elements to say, well, this part should be in this domain. You can handhold all of this with glob patterns and such, right? So once you have your compose element, we send it to this x86 image element is basically a script that we have in BST external repository. And this one does, it basically does what Wick does from Yocto. It was generally based on what it was doing. So there's a lot of new, maybe 5 or 10 years, recent enough options to file system tools like MKFS to allow you to generate images using the data that you have in a directory without ever becoming root, right? So that in conjunction with a DOS partition and another user space utility, and syslinux lets you splice partitions of an image into something that you can boot without needing a loopback mount or anything that you're not allowed to do on your user. So that's one configuration. This is another example of how we do Flatpaks, and that's coming this week, I think, next week. We were looking at a release last week of the Free Desktop SDK project. So basically, this is how we would build the GNOME stack. First, we would import the Free Desktop, which is already built. It was previously built with Yocto plus Flatpak Builder for the 1.6 SDKs and runtimes. We're building them with BuildStream from the bootstrap up with the Free Desktop SDK project in 1.8. Here we just take the same build metadata that developers use on a day-to-day basis to build and test, but we build it on top of this SDK. And then we use similar compose things, right? Compose lets you, we're gonna like split out the locale extension of a Flatpak. I'm not sure how, I think maybe half of the audience is very familiar with Flatpak and knows what I'm talking about, but you have like, SDKs have different, they have mounts of sorts. You have locale, you have debug, you have different things, split them out. And here you just put some fairy dust, which is like flatpak.meta or something, which informs Flatpak runtime what to do about portals and stuff. Permissions and such metadata that Flatpak would understand, but I have no idea. And then you get a checkout that you can make an OS tree repo and deploy it as a Flatpak, right? For today we have a demo. It's not what I wanted, but at least it's half of what I wanted. So in this demo, we can see it a little bit better here. In this demo, I'm going to build Glade on top of a very specific Debian base, and then I'm going to generate a Glade package in that environment targeting the Debian version which I staged, using Debian tooling which was staged as part of that import process from OS tree, right? So here we have a bit of a sample of what BST files look like. This is basically an import element. It says, let's bring stuff into the pipeline using an OS tree source at a given URL with a GPG key that I'm revisioning locally to check my download from that OS tree repo, that it's sane and it's signed by the people I expect. And we're using AMD64, and we have a ref, right? And then we have to do this something that's actually a bit more freaky, because so the import, we've imported that multi-strap thing, but the multi-strap thing it doesn't configure because it's running on AArch64 and it does like a bunch of different architectures. So we have to, when you get onto a host that you know is going to build, we stage it all and we run dpackage configure, and we add a little bit to that to like remove stuff that we don't want and to tiptoe around its possibly failing without being really root. And since we have the install root here, that indicates that this script element, so it's just a script element which runs commands. It stages this, it runs some commands, and because it said the install root is slash, the entire output is the entire sysroot, and it's just basically done a transformation on it. And the output is what we want because that's an environment we know is safe to execute in. So then when we build Glade, we just use an AutoTools element because it's nice and slow, unlike Mezen. So it adds padding to your build time in the demo when you have like minutes to burn in the conference. Yeah, so basically we just say, I depend on this sysroot, which I just previously configured, and stage me these sources. So this is the sources I want to build. I'm using an alias to like http //gnome glade.git, right? And here we have some interesting stuff. The public data. So basically everything we've seen so far is either core BuildStream format or configurations that are declared by the plugins which implement them, and that's all validated. So if ever you specify a typo or an invalid value or something, you're going to get an early abort. But the public data is completely free form, and what's special about it is in a pipeline such as this, every element can see the public data on all of the elements it depends on, right? So a given element can say this is some metadata that a later element can consume, and it doesn't have to be bound to any API constraints. It's rather free form. So this is actually informing this element, the dpackage deploy element. What are the things you're going to need to know to be able to make a package out of me, right? Then we move to, this is, most of this happens in Python in a custom element, so we don't see a lot of script here. But basically, this one, the dpackage deploy element, is going to take the input artifact, so that's part of the dpackage deploy's custom element configuration, which says tell me what you want me to package and tell me what part of my dependencies is the base, right? Because he has to decide, well, I'm going to stage all of this dependencies and try to run on it, right? Surf on it. And this other dependency, I'm not putting it there, I'm just going to build it, right? So it puts it in different parts of the sandbox, and one of them is the execution environment, and the other one is what it's going to do something with. It's going to package something. Yes. So I have a feeling that we might be able to see a bit better here, right? I better just, okay. What do we have here? So this is the project, right? So that's where we have that key which verifies the input. And here we have our elements. And we have our cached elements. Nice and big, okay. And they're already built, so I can't really build them for you right now. Maybe I could. We'll try that after, if we have time. So, I want to take a look at, I'm going to check out that last element from the slides, right? We're going to check it out in a location, and that is there, right? And what this depackage element did, it just went through the different domains that we use for splitting by default. And we say, okay, there's different categories for stuff. And we just said, well, I'm going to take everything in the runtime package and put it in a runtime. And it's really stupid and straightforward, but it can be tweaked. And those categories of files, those split domains as we call them, can also be configured so you can do more fancy stuff. And it's a work in progress, right? Which is why it doesn't install cleanly on my OS. So I don't have a Glade, right? And I'm doing FOSDEM. Let me see what, I think what happened when I did without FOSDEM, it said you don't have, yeah, so architecture, we didn't sort that out. And there's also, isn't there missing description? Yeah. Oh, it needs some description in the metadata. Huh?
That's not fatal, that's just a warning.
That's just a warning? Okay, yeah. Any was a bad mistake, you know? There's a, well, that's really bad. Don't do this, right? But, you know, it works, right? Except that the display is very, very small, right? But basically you can use it, and it's running on my host against my host libraries. And what's interesting is that I'm running Debian Stretch, and that was, so yeah, it's not, I should have built it against Debian Stretch, but I had only a testing runtime available at the moment. So, but what's interesting is you can target specific versions, and you can develop your package for Fedora or for Debian or for whichever on your Gen 2 machine, and actually the host should never be relevant in what you're building anyway, right? Because your host is always just a moving target. So I think that's pretty cool. And right now we're getting into the, soon we're going to have Q&A, but should I, let's see. Whoops. Now we said architecture AMD64, right? Yes. Yes, huh? Okay. Okay. So I'm curious to see if I killed a warning with this, and oh my. Okay, So we failed our 80 character terminal with Sam. I'm sorry. This is horrible. Outrageous. No. This is horrible. I know. There we go. Oh, but then nobody can see anymore, huh? Oh. Yeah. Okay. Ah. Yay. Okay. And that should be the same, yeah. Okay. So it's time for the Spanish Inquisition. Yes.
So when you're building binary packages for Debian here or Fedora or whatever, am I right in saying that you're skipping straight past the source package stage?
Yes.
And going directly to essentially a glorified tarball? So you have a Debian package, a .dev here that has never had .dsc, or in Fedora land you'd have RPMs that there just has never been a corresponding SRPM.
Yes.
Right.
Basically, so we want to use the same build instructions, right? And we want to treat the packaging systems as only a packaging system and not a build system, right?
So these packages can only ever be like released, uploaded, whatever, to a distribution that has like made a decision that this is an okay way of working.
Yes.
I could hook on to that. I had a question about, I realize this is all generic, but in practice, the compose stage and the image stage, once you have caching of the artifacts, those stages tend to be quite long and take a lot of time, and especially if you were going to build source package, unpack that and sort of have all of this package. And could you comment on how we could improve those stages so you actually get the minimal amount of work for this tiny change that we make?
Okay, so
Or just explain in practice what happens in those stages in your example. Do you
well,
take a bunch of depths and unpack them? Do you unpack all the depths for the entire
in the beginning,
process, or?
to create a sys root to build on top of.
No, in the compose and image building stage, the last two stages you have.
Okay.
The bootable system.
So there, in that example, we don't use packages at all.
Okay.
Right? But there's another project that we have which does, except it's not using BuildStream yet. And we have something similar which creates the packages for RPM using -bb to skip the build steps. And it will use like RPM install --sysroot into a place, and it will do that. But that's especially because it was for an organization which was using RPMs and using Migo image creator.
For the one package, I guess that's okay, but what I'm looking for is, can you start with all the stuff that hasn't changed? Like, would you integrate something like OS3 to get the minimal amount of work to change, create a root file system based on what another one that is
There is
similar? I mean, that kind of tracking of changes on that file level.
That's very difficult to do. Yeah, that's that on the file level we don't have that really. No, it's one shot.
It's the next
Compose.
step,
For compose, it's very doable, and for the image, constructing the image is very tricky because you have partitions and you need to splice them. But yeah, it's difficult. Anybody else? Yes.
How do you get your initial bootstrap environment? So like enough compiler to compile the rest of your system and that kind of thing?
So Javier and Adam are working on the Free Desktop SDK project. Adam's behind you, and they are doing a project which does the bootstrap, and I'm not sure where they are with it yet, but basically, yeah. I'm just not sure about what's the input going into the cycle, but it should be circular at this time. So you basically have glibc, GCC, BusyBox, and I think you need GNU sed to get through the build of GCC. And
so that's completely orthogonal to BuildStream, is it?
Yeah. Well, BuildStream has been doing these bootstraps since the beginning because it's very important to us to know that we can. Right? But yes, that's a separate project.
You can just import compose random binaries from anywhere if you so wish.
Yeah.
After that.
Yeah, the way it works is the first time we built it, it was from a Free Desktop SDK 1.6 that we were importing, I believe. And now that we've built it once, we commit it, and the first stage is cross. So the first stage, you generate an output with a target, and you never execute on the build any of the binaries that you generate, but then you can import that on a foreign architecture and continue the build from there. Yeah. Yes.
How many projects have been like ported to have the metadata and rebuildable? Any
So during the past, like since Guadec, we've had a system going on where we were building from conversions of JHBuild. So as far as GNOME goes, there's everything that was in JHBuild sans the apps, because release team wants to make the distinction where apps go into Flatpaks and only core gets built separately. So those are currently being built with BuildStream, and Javier should get CI online next week so that we have auto builds. Aside from that, other projects which cannot be spoken of. Yeah, I'm hoping to get to a point where I can make Flatpaks of Glade and like have it myself, and we're going to talk with Alexander Larson about having support in FlatHub as well. Yeah. Ignacio.
All other platforms.
Other BSD. That's what you mean, like not other architectures, other platforms.
Yeah.
Right. So we have a Unix backend, because right now by default on Linux we use bubble wrap for the containers and we use OSTree for the artifact cache, because they're optimal solutions for the problem, and we have a lot of Unixes out there which just don't have that, and doesn't really make sense to like make OSTree supported. I don't think that's going to fly for every different platform, AIX, Solaris, right? So we have a Unix platform backend which requires root, and you do a chroot and you use tarballs instead. We have somebody, I forget his name, last week came in and started testing building GNOME on BSD, and he's got some like hack patches that we can inspect and use it to fix it for BSD, but we want to make better platforms for specific targets using the technologies which exist on those targets. Windows is a long time coming, I think. It's not next week.
Windows services Microsoft.
Well,
Thank you very much. That was our last question.
okay.